Alright, so lesson 11.3 polygons. So here's the deal. I would have had you do an activity, but we don't have time. I did this activity with the other kids yesterday. And what I had them do is I had a whole sheet of shapes, and they cut them out. And then I had them classify these shapes into different, I don't know, sections or different groups. Thank you, different groups. And then we talked about each of these shapes and what they look like. But, sorry, can't do that today. We have some vocab. And I have quite a bit of vocab actually today, so.
We have like 10 words, they're all this long.
I will talk about these after you get them written. You know what? Maybe a little bit. Maybe a little bit. But not like I wish I would have done it, because I think Brunsma was here then. And I would have taught it a little different than he did. But that's okay. Everybody's different. It's because I've been doing this forever. More than him. He was very good, though. He's very smart. He was very smart. He's very good. Alright, so a polygon. A polygon is a figure with 3 or more sides. And they have to be straight sides. Anything up on that black poster up there is a polygon. Okay? And it can go higher than that. I mean, a decagon, that's a 10-sided polygon. And there's polygons that are 100 sides, and, 15 sides, or whatever. Okay, but we aren't really going to know those names. My gosh, it would take us forever to figure out the names. Okay? So anything that has 3 or more sides, and it's a closed figure. So you can't have a figure that looks like this. That's not a polygon because it's not closed. No, it is. Okay. Now you got to remember, doesn't have to look exactly like that. You could have a 5-sided figure that looks like this. 1, 2, 3, 4, 5, and that would be a pentagon. Okay. Not all pentagons have to look like that. Not all octagons have to look like that. Those up there are just known as the regular polygons, and I'll get to that in a second. Okay? Vertex, this is where 2 sides meet. So like this would be a vertex where 2 sides meet. This would be a vertex, 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 vertex. So anytime there's like where 2 sides meet, but basically a point, okay, is a vertex. And a polygon is classified by how many sides it has. So if you need to know some of these you probably know off the top of your head. You know a triangle has 3 sides. Quadrilateral, you know, has 4 sides. But maybe you don't know pentagon, hexagon, heptagon, octagon. And so that would be something just to jot down. You probably know octagon has 8 sides. Okay? You maybe get confused at pentagon, hexagon, heptagon. So if you don't know some of these, make sure you get them written in your notebook, because you're going to want to know this for your homework today. Okay? And you're not always going to be able to see my sign up there. So if you don't know some of these, make sure you get them written. Yep, usually. Gone. Yep. Yep. It would practically be a circle. Why? Because all the sides would pretty much be almost straight lines, and now I'll just look like this, but you're right. Okay, so any questions on this so far? Nonagon is 9, if you want to know that one. If you don't know decagon, that's 10. I don't have those up here, but I believe they're in your homework today. So nonagon has 9, and decagon has 10. And then usually if they talk about anything higher than that, they'll say this. They'll go like 11, oops. They'll say like 11gon. That just means like 11-sided shape, or like 20gon, that means 20-sided shape. So usually, usually decagon be 10. Usually they only go up to 10, and after that they start doing stuff like this because you don't know off the top of your head what 11 side shape is called. I don't either. So that's why they do it this way. All right, now a regular polygon, this is what I was talking about before. Okay, a regular polygon is a polygon that has all the same sides and the same angles. So everything is congruent on it. All the same sides and all the same angles. So basically everything up on that poster is a regular polygon except for the quadrilateral. They have it as a rectangle. That's not regular. Because why? It doesn't have the same sides. What quadrilateral would be a regular polygon? A square, yeah, it's got all the same sides, all the same angles. That's why I have this one right here. If I look at this one, would this be considered a regular polygon? No, but it's still a triangle, right? It's okay. They don't all have to be regular. It's still a polygon, but this is not regular. What about this one? No. Polygon, though? No, what kind of polygon? It's irregular, but it's a five-sided, so it's a five-sided pentagon, but it's an irregular pentagon is what it is. What about this? Yes, because I know all the sides and all the angles are equal. So how many sides is this? 1, 2, 3, 4, 5, 6, 7. Heptagon. Okay. So in your homework today, what they're going to do is they're going to give you weird-looking shapes, and they're going to ask you if that's a polygon. Is that a polygon? Yes. Okay. How many sides does it have? I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9 about. I would say about 9. So it's a nonagon. Is it a regular nonagon? No, because not all the sides and all the angles are the same length and same size. So you know the difference between the two. Yes? Okay. Next vocab I have is diagonal. And we're going to use diagonals a little bit today, coming up. Diagonal connects two vertices that do not share a side. So basically we can draw a line from one corner to another corner. That's what a diagonal is, one corner to another corner. Okay, so pay attention because this is important for our next two vocab. Diagonals are anyway. It's up to you if you want to know what it looks like, maybe. Sometimes you do better with pictures than anything. Alright, can I go to the next slide? Okay. So then we have two different types of polygons, too. We have convex polygons, and we have something called concave polygons. Okay? Concave, okay. Convex. Okay, so a convex polygon is when you can put diagonals inside and all the diagonals will stay inside the polygon. So do you see what it looks like? So the blue things are my diagonals there. My polygon is like a pentagon, just not regular, but that's okay. And I connected all my vertices to what can be connected. No, it doesn't really look like something. Yeah, it kind of does. Oh, you're right. Then concave means that if you would have a polygon, you could draw a diagonal outside of the figure. So like, see how my figure looked like this? Okay. Maybe you draw some diagonals. Maybe there's diagonal here and here. And all of a sudden, you're going to connect this one from here to here. Guess what? It goes outside of that. If you're going to connect this two down here, guess what? It's on the outside of the polygon. Okay. So all the diagonals, I guess I should say all. Some of the diagonals in a concave polygon are going to be on the outside of the figure. So that's the difference between the two. So convex is all the diagonals can be on the inside, and a concave is some of them are possibly on the outside. No. I don't even think this is in the homework, but I just think it's interesting to know. Questions so far? Good? This is a long lesson today. I'm just going to FYI you. and it should not be. Any questions so far? Good to go? So how many sides does a polygon have? 3 or more, it can be unlimited. Do they all have to be regular? No. What is, has to be closed, you're right. Yep, has to be straight line. Circle, not a polygon. Okay. Good. All right, so here's my next thing. Okay, so they're going to give us a polygon, and we're going to try to figure out what all the angles add up to on that polygon. Okay, so maybe let me insert a page here. And let me insert a polygon. Let's just insert like a 6-sided one. Okay, so what we're going to do is we're going to be given a polygon, and we got to figure out, okay, if we would cut this one off, oops, we would cut this one off, and 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 this one off, what the sum of all of them together would be. All the angles, yep. Now, do you have any guesses? No, our job is to figure it out. But it's simple, believe it or not. You think, okay, maybe 120 a piece, but I want to know all together. And how do I know exactly if it's 120? If it's equals to 360, if I just look at 2 of these already, I know it's going to be over 180. So I know 4 of them are for sure going to be over 360. See what I'm talking about? See how big they are? So they're not, guess what? Not every polygon is going to have the same degrees inside of it. Okay? So here's an easy way to figure this out. What are some things you know already about polygons? I mean, we looked at triangles by itself. What do we know about triangles? Okay, what do we know about the angles though? Okay, so we're going to use that from what we know to figure out the angles in here. Anybody got any other guesses now? What can we do with triangles now to figure out how many degrees are on this thing? What? Put them in there? I don't know what that means, but yeah. Be my guess. You're already half out of your seat. That's not an equilateral. That's a rectangle now. You're still close. I want you to go back to this. Go back to this. Okay? Go back to this. What did he already make? Okay. What else? Okay, so that's one triangle. Can he make more triangles out of here? Yeah. If I go from here to here, what's that? If I go from here to here, what's this? And what's this? How many triangles are there? Can I take 180 times 4 and that's going to tell me the sum of the angles? Pretty simple, right? Okay, let's go to the next page. So here I used a pentagon, I believe. Let's go this way. Oops. Here's a pentagon. Oh, come back. Here's a pentagon. How many sides does a pentagon have? 5. How many sides? Okay, 5 sides. I did just what I decided to do. I went back to the same vertex and I drew lines to every single vertex. Diagonals to every single vertex. How many triangles were there? Okay. Now let's go to this right here. This is an octagon. How many sides does an octagon have? How many sides does an octagon have? How many triangles did I get out of it? Okay, do you see a pattern here? What's happening? It goes down 2 every time. Did you notice that? So no matter how many sides I have, how many triangles am I going to have? 2 less every single time. Okay? And then what did we do? We took our triangles and times it by 180, right? That's the equation right here. N is the number of sides. So they're going to give you a polygon, and they're going to ask you to find the total sum of the angles. Now, do you have to draw and put the triangles in it? No, because you have the equation. So you're going to take the number of sides minus 2, and you're going to times by 180, and that's going to, you don't even have to make the triangles. But I wanted to show you why the equation worked before I showed it to you. This works for everything. Regular, only regular. Yep, only regular. Alright, so let's figure this out. I'll do my calculator speed to some time. So, this one, 5 sides. Well, 5 minus 2 is 3, so 3 times 180. 540 would be the degrees if I would add all of them together. This one over here would be 6 times 180 would be 1,080 degrees altogether. So not every one is going to be the same. Not all of them are 360. Not all of them are 180. Everything is different for polygons. Okay? So you catching how this is going? Okay, so let's do another one. Let's do another one. I want you to do it. Let's say I have a 15-sided figure. Let's figure out all the sum of all the angles inside. What am I going to do? 13, which would be 15 minus 2 times 180. And I'll just do it quick. This is how many degrees would be together in there. Okay? Now let's think about this. If this is all of the angles in here, what if I just want to find one of them now? If I know, I'm going to do what? I'm going to divide by what? Why 15 and not 13? That's the original. Very good. That's the original. That tells me how many angles there really are. If it's a 15-sided figure, there's really 15 angles in there, you guys. Okay? Not 13. We just had to figure out how many sides. We got to figure that out. So if I divide this by 15, let's divide that by 15. Each angle is going to be 156 degrees. You guys catching how this is going now? So first we had to figure out how many altogether, and then we can use that to figure out what one angle is dividing by how many sides there are. Okay. Questions so far? So let's go back. I'll wait a second if you're still writing from this. Let's go back a page. Can I go back a page? Are you using this yet? Okay. So now, say if I know this pentagon has a 540 angles altogether, how can I figure out what one is now? 540. Anybody got any guesses how many it is? 108. 108. Got the 0. Okay. Does that make sense to everybody? How that works? Now about this one, how would I do this one? I take 1,080 and divide by 8. And it would be 135. Okay, now in your homework today, it's going to ask you to do two things. It's going to say, find what one angle is. Do you have to do it all to get the one angle? You do. But some of them might say, just find the sum of all of them. Then what do I got to do? I just got to do the first part. I don't have to do the second part then. So you have to read your directions carefully. Okay? Not done yet. We're very close. A lot of it, yeah. This is my next part of the assignment. What? You never had this. You never had this. Okay, tessellation. This is my last vocab. Okay. Okay, writing. So we only got about 10 minutes left. Tessellation. I think I spelled that wrong. I think it has 12 in it. When the sum of the angles where the vertices meet equals 360 degrees. So you're like, what? Basically what a tessellation is, it's a pattern without any spaces in it. It's a pattern without any spaces in it. Okay? You did do this in 4th grade. Somebody already told me that. If I had more time, I'd make you do your own. They're actually kind of fun. So, if I look at this, let's just look at this vertex right here. Can you guys see that? Is it weird on your eyes? Sorry. That's the best one I could find on the internet. So let's say this is my vertex. Remember where the points meet? That's a vertex. Okay? That means that this angle, and this angle, and this angle, and this angle, guess what it has to equal? 360 degrees, because I just make a circle. Okay? So our job today is they're going to give us a polygon, and they're going to ask us if it will tessellate, which means that if we put it together, will it automatically go together without any spaces? Okay? And there's ways we can figure that out by using everything we know now. Okay? So, for example, what's that? This tessellates. This tessellates. So now let's figure out. So let's see if a pentagon can tessellate. So I made some steps for you. The first step is doing everything we just did. You're given the pentagon. It's got 5 sides. Yes. And I'll do it in steps for you. So first step is to figure out the sum of all the degrees. Like we just did, we used our equation, and then find what one degree, or what one angle is. You guys know how to do that. Just did that. So you're going to find the sum of all of them, and then you're going to break it down to what one of them would be. Number 2, you're going to take 360 and divide it by the number of degrees you found out in number 1. And then 3, if there's no decimal, it does tessellate. And if there is a decimal, it does not tessellate. So if there is no decimal, it does tessellate, and if there's not a decimal, it does. Oh wait, did I say that right? If there's no decimal, it does tessellate. If there is a decimal, then it does not. And I will do this in steps for you so you can see how it works. Right. I will show you. Okay? So let's do this first. So, then. It should be then. Does that help? There we go. There we go. What each angle is then. Okay, so first thing you're going to do is you're going to start and you're going to find out the sum. And we did that already before. Remember in the back one? So we did 3 times 180 and it equaled 540. Remember that? And then we're going to divide by what to find out what one of them is? 5. It's a pentagon. No, that's like my arrow. Sorry, my bad. So I'm going to divide by 5. So what is one angle then? 108, remember? Remember we did that back here? Remember we did that right here? Okay. So that's number 1. Number 2, where's my arrow? Not a 7. You're going to take 360 and you're going to divide by this number. Okay? Oh, 108, my bad. Not 180. Okay, now if I look at this, is 360 going to be divided evenly by 108? You probably already know. What are some things that would evenly divide 360? 36, 60, 120, 180, okay, 10, yep, 5, right? Okay, thank you. Okay, so I already know off the top of my head 360 divided by 108 is going to give me a decimal. It's not going to come out as a whole number. So if it does not come out as a whole number, so let's say it comes out, I think it's like 100, 3.3. 360 divided by 108 is 3.3. So it's giving me a decimal. So does it tessellate? No. That means I can't put pentagons together to make a circle. Does not work. I'm either going to have overlap or not quite enough. Okay. How are we doing so far? So far, so good? Okay, let's do another one. Let's do an octagon. Okay. You can try it on your own if you want. We already did an octagon in the last page too. So first step, you would do 8 minus 2 times 180. So it would be 6 times 180, and I believe it's 1,080. Okay, but I got to divide by 8. This is what it gives me. So 2. Remember what you're going to do next? Some of you are doing it by yourself, that's fine. then I'm going to do 360 divided by 135. You can probably tell what this is going to be already. So does it tessellate? No. It's going to be, let's see, 360 divided by 135 is 2.6 repeating. Now, if we had one that came out like just regular 3, then it would. Or just a regular 4, then it would. But if it has a decimal on the end, it's not going to. If it comes out as a whole number, it will. Okay. Okay, so how are we feeling here, people? Any questions? Okay, get out your homework because I would like to discuss